Hey Algebra 2 class, just making a quick video here to explain to you how to not only find the vertex axis of symmetry and whether a graph faces up or down with vertex form, but also with what we call standard form. Alright, so vertex form is your transformation form. That's what we've been working on. So that is my vertex form, a x minus h squared plus k. That's my vertex form of a quadratic. We can put the function notation in front. Standard form is when that's all multiplied out, and so you get f of x equals ax squared. So a is the same variable in both, it represents a constant, plus bx plus c, where c is your constant, all right? And so this c also represents your y-intercept, just for some fun facts here. It's not the same as k, though. C and k are different letters for a reason. C is the y-intercept, k is your vertical shift, which we know doesn't always have to be on the y-axis, okay? So one of the things that we want to be able to do is determine whether the function given, the equation, is written in vertex form or in standard form, because there are two different ways to graph a vertex form versus a standard form equation. So number one, when I see the parentheses, like quantity x minus 4 squared, that tells me this is in vertex form. All right. When I see negative 2x squared, and then a term with just an x, and then a constant, and it might not have all three of those pieces, it might only have two. For example, there might not be a plus 9 at the end or something like that. That would be considered standard form. All right, just like lines, there are multiple forms of equations. So standard form would be number 2. Okay, so we've talked about vertex form at length. You're probably sick of listening to me say this by now. But to find the axis of symmetry, right, my A, my H, and my K, I first need to pick out. Well, A would be the number in front of the parentheses or in front of the X, which is nothing there, so it's a 1. H is going to be the horizontal shift, so if it's X minus 4, I've gone 4 spaces to the right. Remember, it's always opposite. And plus 3 is K. All right. So that tells me that for part B, the axis of symmetry is x equals 4, and the vertex is 4, 3. Axis of symmetry is always x equals h, so that guy right there is my axis of symmetry. And then putting together the horizontal and the vertical shift creates the vertex point 4, 3. All right. And then lastly, determining whether the graph has a maximum or a minimum point. Well, that's determined by the a value. So since a is equal to positive 1, if it's positive, the graph faces up. And if a graph faces up, then it must have a minimum value. Okay, the minimum of this function is going to be the vertex point. All right. So the minimum is 4, 3, or more generally, we just refer to the minimum as the y value. So the lowest point on the graph would be at 3, okay? So that's in vertex form. Those are the 3 pieces that you're trying to identify. In standard form, which is like what we have in number 2, we have to look for not A, H, and K, but A, B, and C, right? So A is always the number in front of x squared. So in this case, that would be negative 2. And remember, we call those numbers in front of variables coefficients, right? B is the number in front of x, and yes, we're going to take the sign with it. So B would be negative 8. And then C is the constant, and again, take the sign with it. Oops. So C would be positive 9. All right. So to find the axis of symmetry here, we actually have to do a little bit more work when it's in standard form because it's not set up to show us the horizontal shift. We can't see the horizontal shift yet. So for the axis of symmetry, I need this little formula. X is equal to negative b divided by 2a. That's what I have to use every time we have a standard form equation. And I just need to substitute in a and b into this problem. So this would become, well, my b is negative 8, so I have negative 8 divided by 2 times negative 2, which would be positive 8 divided by negative 4, which would be negative 2. All right. So that is my axis of symmetry. That's the x value where the center of this graph will be. To find the vertex, we need to substitute the axis of symmetry into the function. So negative 2 becomes my input, so essentially I need to find f of negative 2. So I'm going to look here. I would have negative 2 times negative 2 squared minus 8 times negative 2 plus 9. So negative 2 times 4 plus 16 plus 9, negative 8 plus 16 plus 9 would be 8 plus 9, or 17. Oops. All right, so f of negative 2 is equal to 17. I'll sort of erase that in a minute so I don't bleed into the next thing. So that is my vertex. That's the y value of my vertex, right? Oh, let me use a different color. So the vertex is actually the point negative 2, comma 17. So the x value comes from the axis of symmetry right there, and the y value comes from substituting that in. Okay. And then part C is asking, does this graph face up or down? Does it have a maximum or a minimum? Well, again, let's look at the a value, right? So if a is negative 2, then the graph faces down, which would look like this, right? So then that point has to be a maximum, okay? The vertex of your function here would be a maximum, all right? So two different ways to, excuse me, to identify that information depending on which form you're given. You have to use that particular method. So for given vertex form, look for your horizontal and vertical shifts to find the vertex. If you're given standard form, you have to remember this golden little formula, negative b over 2a. That comes from the quadratic formula, and we'll talk about sort of where that comes from pretty soon. But you want to use that little formula to actually find your axis of symmetry, okay? And we need that number in order to also find the vertex. So go ahead and give the rest of this page a try, and let me know if you have questions.